Hey guys, welcome to my video on exponent rules. Today we're going to refresh our memories on all the different rules we have when multiplying variables with exponents. Okay, so the first rule we're going to focus on is called the product rule. Okay, the product rule says when you multiply and the two bases are the same, you are going to add the exponents. Okay, so here we have x to the m times x to the n. When we multiply those two things together, we add our exponents to m plus n. So when we take a look at a, x to the third times x to the eighth, that becomes x to the 3 plus 8, which is x to the 11th, okay? So again, we have two bases. They are the same, and they're multiplied. We add them together. So here in question B, we have the similar situation, except this time our base is not a variable. This time our base is a value. That doesn't change the question. The base still stays the same, and we are still going to add our exponents. So 4 plus 2 is 6. Okay, so you could leave that as 2 to the 6th, or you can type it into your calculator to get a value, but in the end, that's equal to 64. The most common mistake with questions like this is people write, and I'll put this in blue so you know it's a mistake, 4 to the 6th. They multiply the 2's. If the bases are the same, you have to bring that same base along with us, okay? And it works when we have multiple variables. We just group them by variable. So x squared y times x cubed y to the 4th. Well, we have our x's that are multiplied together. So I'm going to have x, and I'm going to add the exponents to the 5th power. And we have our y's that are multiplied together. So I'm going to add those exponents. Anytime you don't see an exponent, it is assumed to be a 1. So that's 1 plus 4, also 5, okay? And that would be in its most simplified form when we don't have any multiplications left in the question. So let's continue. Now that was multiplication. What happens with quotient? Okay, when we are dividing and we have the same base, right, we write the base and subtract the exponent. So if we take a look at our example, right, x to the 5th over x squared becomes x to the 5 minus 2, which is 3. Remember, it will always be top minus bottom exponent. Okay, so keep that in mind. Rules, the order matters. Top minus bottom. All right, so 3 to the 5th over 3 cubed. Well, do they have the same base? Yes, so that base follows along. Now we subtract our exponents. 5 minus 3. We get 3 squared, which becomes 9. Now you could plug that into your calculator. You should get the same value. Just like it works with multiplication and multiple variables, the same thing's going to happen with division and multiple variables. We take them letter by letter. So x squared over x, so that's 2 minus 1. So that's x to the 1st power, which we don't even have to write 1st power. Y to the 5th over y to the 3rd, that's y to the 5 minus 3, which is 2. Great. All right, let's continue. So what happens when the exponent is 0? Well, we have a rule. Any base except 0 raised to the 0 power is equal to 1. So y to the 0, 1. 6 to the 0, 1. 100 to the 0, 1. What about 7 times a to the 3rd, b to the negative 1 raised to the 0? Doesn't matter, still 1. Okay, so just be careful about that, but that one's relatively self-explanatory. So now we have the power rule. A different power. A power rule. The power rule is basically when you have a variable with an exponent and it is raised to another exponent. We often say power to a power. When we have a power raised to another power, we're going to multiply your exponents. So x to the 3rd to the 2nd becomes x to the 3 times 2, which is x to the 6th. 3 squared to the 4th power, that becomes 3 times 2 to the 2 times 4 is 8. Well, 3 to the 8th is quite a large number. 6, 5, 6, 1. What about z to the 5th squared? Well, that's 5 times 2, z to the 10th. Notice we don't have two bases here. Okay, it's just a power to another power. Okay, now what about when I have multiple things raised to that power, whether it's multiplication or division? Well, as long as there is no addition or subtraction within the parentheses, you can distribute your power. So x gets a copy of m and y gets a copy of m because there's no addition or subtraction. X gets a copy of m, y gets a copy of m because there's no addition or subtraction. So here we would get 2a to the third. Well, that's 2 to the third, a to the third. Okay, the biggest mistake I see people making is they will multiply the 2 times the 3. That's incorrect. We raise 2 to the third power, which is 8, a to the third. 6x to the third squared. Well, that's 6 squared, x to the 6th power. That's 36x squared. All right, same thing with division. Okay, so we're going to raise x squared to the 4th power. We multiply those powers to get 8. Y to the 1st to the 4th becomes y to the 4th. What about the denominator? Now we have a lot of things going on. We have a 2, we have an x, we have a y squared, all raised to the 3rd power. So if it helps, I like to do a step where I give everything that exponent. 3 to the 3rd, y squared to the 3rd, and then I simplify. So 2 to the 3rd is 8. X to the 3rd doesn't need to be simplified. 3 cubed is 27, and y squared cubed is 6, leaving that as your final answer. Okay? How do we handle negative exponents? A negative exponent basically brings that exact expression down to my denominator or to the opposite side of my fraction bar. So if I have x to the negative m, x to the m without the negative will go to my denominator. If I have x to the minus m in my denominator, it will then become x to the m in my numerator. And if I have some complex expression inside of a parentheses raised to a negative value, I can just find the reciprocal of the inside, right, as they did here, and drop the negative in my exponent. So let's take a look at some of these examples. X to the minus 3. Well, that technically is in a numerator because anything can be written over 1. So the reciprocal of that is bringing x to my denominator with a positive exponent. That's it. 4 to the negative 2. Well, again, that's technically over 1. So the reciprocal would be 1 over 4 squared, which is 1 over 16. What about C? Well, negative 4 doesn't have a negative exponent, so it's not going to be moved. X to the 5th does not have a negative exponent, so it's also not going to be moved. So the only thing being moved is the y to the negative 2. So assuming this is all over 1, right? Anything that's not being moved stays in my numerator, and anything being moved will be shifted down to my denominator with a positive exponent. So the final answer there is 4x to the 5th over y squared. All right, let's continue. X squared over y raised to the negative 3rd power. Well, if we want to eliminate the negative when we have a fraction, we can simply just flip that fraction inside and make the exponent positive. And then I can distribute in a regular way. Y cubed over x to the 6th. All right, so again, if we have a fraction, we can do that. What about over here? We have some multiplication. Okay, so the rules are still the same, right? I'm still going to go variable by variable, I'm still going to multiply, so I'm still going to add my exponents. Okay, but the negative exponents this time have to stay. Okay, so looking at this, 3 and a negative 2. Those are just regular coefficients, so they can just be multiplied to a negative 6. X and x to the negative 2 and x to the first. We multiply those, so we add our exponents. So a minus 2 plus a 1 becomes minus 1 as an exponent. And now the y's. We have y to the first plus negative 3. So 1 plus a negative 3 is minus 2. All right. Now, an expression is not simplified unless there are no positive exponents. So what is left for us to do now that we've done our multiplication is we have to move everything that is not with a positive exponent to the other side of the fraction bar. So negative 6 stays because it has no negative exponent. But x to the first moves down and y to the second moves down, making that our final answer. Okay? So I am going to ask you to take a minute to pause the video and try F and G. Okay? See if you can apply multiple rules at the same time. Okay, so what happens here? Well, are there any variables to combine? Well, we have an A, a B, a C, and a D. So no, we do not have any variables to combine. So the only thing left for us to do is to move anything with a negative exponent to the opposite side of my fraction bar. So A to the negative 2, that is going to go into my denominator as A squared because I need it to turn positive. B cubed, on the other hand, is going to stay in my numerator because it does not have a negative exponent. C to the negative 4, we have to move to the opposite side of the fraction bar because of the negative exponent. And D to the negative 1, we're going to move to the opposite side of my fraction bar with a positive exponent. Oop. Making my final answer, B cubed, C to the 4th, D over A squared. Okay, and last but not least, G, we have a parentheses with a power on the outside. What I'm going to do first is I'm going to distribute that, okay? I'm going to distribute the negative 2 to everything in here. So that's negative 2 to the negative 2 power. That's x squared to the negative 2 power. That's y to the negative 4th to the negative 2 power, okay? So how do we simplify negative 2 to the negative 2 power? Well, the negative brings it to my denominator, okay? And then my denominator eventually becomes a 4, okay? What happens in the second one? Well, that's x to the 2 times negative 2, negative 4. What about y's? Negative 4 times negative 2 is 8. All right, so what is my final answer here? Well, I need to move anything with a negative exponent to the opposite side of my fraction bar and simplify any values that I have. So what stays in my numerator? Y to the 8th. What goes in my denominator? Well, this negative 2 squared becomes a 4. This x to the negative 4 just becomes x to the 4th. Okay, making that my final answer. All right, so 2 things to remember, and then we can go on to our practice. Remember, a negative coefficient does not mean I flip it. Okay, so if it just has a negative number in front and it is not in the exponent, you cannot apply the negative exponent rules. Okay, second, an exponent only applies to a factor if it is directly next to it, unless there's a parentheses, okay? So that's particularly important with negative values. So negative 3 squared is negative 3 times negative 3, which becomes positive, whereas negative 3 squared, without parentheses, carries the negative with us. Okay, so that's it for my exponent rules.